In this presentation, we're going to talk about recursion, but before we do, make sure that you've seen the presentation on function stacks because we're going to be tracing through a recursive function. So to begin with, we'll look at the factorial function, and if I were to ask you what is 6 factorial, you would probably say that that's the same thing as 6 times 5 times 4 times 3 times 2 times 1, and technically you would be correct. But what if I asked you what is 75 factorial? You would probably say that's the same thing as 75 times 74 times 73, all the way down to 1, and you would be right. But you could also say that 75 factorial is the same thing as 75 times 74 factorial. So notice that factorial can be defined in terms of itself. However, we still have to figure out what 74 factorial is. So when we do that, we then have to figure out what 73 factorial is. And to figure out what 73 factorial is, we have to figure out what 72 factorial is. And then the question is, when would it stop? Well, generically, we can describe factorial in terms of itself by saying that n factorial is the same thing as n times n minus 1 factorial. So let's jump back to recursion. What is recursion? Well, it's fairly straightforward. It's when a method calls itself, and therefore it's easy to identify. Now what's going to happen is that we're going to create a series of clones on the function stack, and usually the clone has a smaller problem of work to work with. There are 3 different requirements for recursion. First of all, you have to have the recursive call. Second of all, you have to have some kind of terminating condition. And then finally, you have to make some kind of progress towards terminating. What would the factorial function look like? Well, this is a pretty standard version of it right here, but I want to modify it and I want to put in a couple of print statements because it's really important for you to see how this thing is actually working. Also, I've put the function stack over here to the right, and we know that we're going to start with main down here on the bottom. Now look at what main has done. It's called factorial of 4, so what do you suppose is going to happen? Well, we have to create this 4 clone. And notice that the 4 clone has the value of n is equal to 4, which is why I'm going to call it the 4 clone. So what is this clone going to do? Well, the first thing is that it's going to print out its value of n, which is going to be 4. So a 4 pops up on the screen. And then after that, it's going to do a check to see if n is equal to 1, which it's not. So we can skip over that. And then it's going to try to calculate its result. So what does the 4 clone think? Well, it says its result is going to be the value of n, which is 4, times whatever the factorial of 3 is going to be. So the question is, what is the factorial of 3? We still have to figure that out, and also notice that we have pending work after we've done that. So we have to wait for the factorial of 3 to finish out before we can come down and do this system.out.println right here. We can't do that yet. We have to wait for this function call to finish. Okay, so let's go ahead and do that. We can create the 3 clone, and you can see that right here, fact of 3. And what is this 3 clone going to do? Well, it's going to print out its version of n, which is 3. So this is an important point. Notice that according to the 3 clone, it thinks that n is equal to 3, but a little bit later on down here in the stack at factorial of 4, its version of n is actually still remaining 4. So don't get those 2 versions of n confused. All right, let's continue on. So for the 3 clone, it looks at its value of n and it says, is it equal to 1? It's not. So we can skip down to the else. And it tries to figure out its own result. So what's going to happen? The result for this clone says that it's going to be 3 times whatever factorial of n minus 1 is going to be, which is factorial of 2. So you can see that's on the stack right here. And also notice that this clone, just like the other one, has a lot of pending work. It'd like to come down here and do this system.out.println, but it has to wait for this clone to finish. So let's go ahead and do that. So we put the 2 clone on the top of the stack, and it does the same thing. It prints out a 2 to the screen. We drop down to the next line right here to check to see if it's equal to 1, which it's not. So we jump to the else, and the 2 clone says it's going to calculate a result. It's going to calculate 2 times the factorial of 1. So you can see that right here on the stack. It also has this pending work down here, so we'll go ahead and try to figure out what the factorial of 1 is. So now at the top of the stack here, we have factorial of 1. So its version of n is equal to 1. And what is it going to do? Well, it prints out a 1 to the screen, and this is where it gets interesting. Okay, so if n is equal to 1, it is in this case, what is the factorial of 1 clone going to do? Well, it's going to return 1. So we've now terminated all of these recursive calls, and we're about to collapse the stack back down. Now it says to return a 1. Who is it going to return the 1 to? Well, if we look at the stack here, who created factorial of 1? It was created right here. So because we know that factorial of 1 actually resolves to the value 1, what I can do is I can replace this function call here with the value it resolves to. In other words, I can replace this factorial of 1 with the 1 that we figured out. So we'll go ahead and do that. The factorial of 1 can now die, and then we can do this replacement that we just talked about. Now, factorial of 1 is dead, and factorial of 2 is the one that's at the top of the stack that's active. Notice that factorial 2 had some pending work here. So what is it going to do? Well, it wants to come down here and do system.out.println, and remember its value of n is equal to 2, so you can see that a 2 has popped up on the screen. It too wants to return its result, so let's figure out what that was. Well, it's pretty simple math at this point. It's going to be 2 times the 1 that we figured out. 2 times 1 is equal to 2, so we know that factorial of 2 is equal to 2. Again, who do you think this is going to return its result to? Whoever called it. So we know that the factorial of 2 was called right here. So I'm going to be able to do this substitution here. I know that factorial of 2 is equal to 2, so I can now replace this call right here with the value 2 and remove factorial of 2 off of the stack. Okay, so we can come down here. We're now at the 3 clone. The 3 clone had pending work, so we can come down here and call this system.out.println, so a 3 pops up in the output. We've also figured out now that the result is 3 times 2, and that's a simple multiplication, and that gives us 6. In other words, factorial of 3 is equal to 6. So who was waiting on this result? Well, you can see the same thing is going to happen. We know that factorial of 3 is equal to 6, so we can replace this right here with the value 6, and we can remove the factorial of 3 off of the stack. Then finally we can come down here to the first clone that we created, factorial of 4, and you can see that we now resolve this to say that it's going to be 4 times 6, which is 24, and the same thing is going to happen right here. We're going to print out our value of n, so a 4 pops up on the screen, and it's going to return its result. Well, who was the one that kicked it off right here? You can see that that was main, so we can now remove factorial of 4 off of the stack, and we can replace this call right here with the value of 24. As a last step, what we could do is we can print out here the value of f, so the final output is going to be 4321, 234, and then the value 24. So hopefully that helps you understand a little bit about how to trace through recursive functions. It's going to take you a little bit of time to get comfortable with this, and the recursive functions will get progressively harder as you go into later and later classes. So that's it for now, and I hope to see you in the next tutorial.